Hi guys, welcome to this, our first lesson on the topic of statistics. And in this lesson, I'm just going to very quickly just remind you of the different types of data before we look at how to mess around with them. All right, so I'm going to drop us in our notes there on page 4. And on page 4, you can just see that the key definitions that I should be able to give for Leaving Cert. So just make sure you can identify the different types of data and give an example of each. All right, so you can see that the data essentially is just information or measurements gathered during a survey or an experiment. Okay, so it's instead of information or measurements that are gathered during surveys or experiments. And there's essentially 4 types of data that I should be familiar with. First of all, I should be able to explain what categorical data is. Categorical data essentially it's not numbers. It's usually words. So it's not usually measured in numbers. Okay, it's categorical data, and there's 2 types of categorical data. Okay, it can be either nominal or ordinal, and the difference in those two is whether it can be put in order or not. Obviously, the word ordinal has order kind of in there. Okay, so it comes from the word order. So ordinal data can be arranged in a logical order. So the good example there is like restaurant service, where you're going to say it's excellent, good, satisfactory, poor, very poor. Because obviously excellent is better than good, good is better than satisfactory. So there is a natural order, a logical order you can put that in. That's ordinal data. Nominal is when there's no natural order. For example, blood groups. So A, B, or O, or if you're dealing with yes, no questions. And there's no natural order to those there. So categorical data is data that's not measured in numbers. And if it can be put in a logical order, it's ordinal. If it can't, it's nominal. And then if you're looking at the other type of data, then the other type of data is numerical, right, or quantitative. So numerical data is one that's measured in numbers. And the 2 types of numerical data, they can be either discrete or continuous. And these can be sometimes tricky to distinguish between whether numerical data is discrete or continuous. That discrete means it can only have certain values in a given range. And continuous means it can have any value within a given range. Right? So make sure you stress the given range. So for example, if you're dealing with heights as a continuous variable, saying that somebody can have any height at all is not accurate. I mean, you can't have somebody that's 22 feet tall. So it's not that it can have any value. It can have any value within a given range. So once you've kind of worked out what the biggest possible height and smallest possible height for a human is, and anybody can have a height, any value between those two within that range is a possible height for somebody. Okay, so it can have any value within a given range. I've always found very useful to distinguish between them is that idea there that discrete is stuff that you count, not measured. Whereas continuous is something that you measure, you don't count. So for example, if you're looking at the number of rooms in somebody's house, you'll count how many rooms there are. Okay, so that's discrete data because it can only have certain values. It has to be a whole number. Again, it's not that it can have any value at all. You're not going to have a room with 2,000, a house with 2,000 rooms in there. Okay, but the key thing is you can only have whole number values. Okay, and you count the number of rooms, you don't measure them. Whereas things like height, weights, and times as are given there, they're things you measure. They're continuous data. So if you're in any kind of doubt in your own head about whether something is continuous or discrete, ask yourself, would you count it or measure it? If you count it, it's almost certainly discrete data. If you'd measure it, it's almost certainly continuous. Okay, and the last 2 then, just to go very quickly, so primary data is obviously it's gathered by the person who's going to use it. So if you carry out a survey, of your own, and you're going to use the numbers of those results in your calculations, that's primary data. Secondary is the data is not gathered by the person who's going to use it. All right, so somebody else gathered. So for example, if you look for results to something online, you use somebody else's results to do some collation, and that's secondary data. You didn't gather the data, you're using data that somebody else gathered. And then univariate and bivariate. For junior cert, the only data you need is univariate data, which basically means one variable. Univariate, one variable. It means you just gather one piece of data from every respondent. So everybody you ask a question gives you one piece of data. Okay, that's univariate data. Most data we deal with for Leaving Cert is univariate. But bivariate data is when you gather 2 pieces of information from every respondent. You ask everybody 2 questions. And the data is paired. And we will be getting to this in a couple of classes' time, working with bivariate data, that you gather pairs of values or pairs of responses from every person. And the only reason you would do that is because you're looking for a relationship between the 2 variables. For example, there's no point in asking people, what age are you and what's your favorite color? Because there's no reason to think there's any link between your age and your favorite color. There's no reason to believe there could be a relationship between those two variables. So there's no reason to pair those particular values. But if you ask everybody, for example, how old is your car and what's it worth? So everybody will give you two pieces of information there. They'll give you a number that represents the age of the car and a number that represents its value, all right? And the reason you would do that is because you suggest that there could be a relationship between those two. That maybe as the age of your car goes up, the car gets older, the value goes down. And we'd investigate that by gathering bivariate data. So the key thing with bivariate is you gather two pieces of data from every respondent, and what you're looking for is a relationship between them. And we'll be dealing in a couple of lessons' time with how we do that. How we deal with bivariate data and establish whether there's a relationship between them or not. So they're the different types of data I should be familiar with. Make sure you can explain what these types of data are and give an example of each.